There are a few ways to solve this question. So I will show you two methods here. Our aim is to find out to determine the current passing through the 2 ohm resistor. We are given that there's a 6 amperes that flows into the junction that splits into two paths past the two resistors of different resistance. So what we can do is, number one, we can identify the current as I1 and I2 in the respective path, and we note that at the junction for a parallel circuit, all the current that enters the junction must be the same as all the current that exits the junction, because the flow of the current must be maintained. So I1 plus I2 gets us 6 amperes. That's our first equation. We can also note that these two resistors are connected in parallel. So when components are connected in parallel, the voltages across them must be the same in parallel branch. So V1 equals to V2. I can rewrite V1 as I1 times 2 using Ohm's law. V equals to IR, and that's how we can get a second equation over here. So now we have two equations with two unknowns, I1 and I2. We can do a simultaneous equation by using the first equation and replacing I1 with 2I2. So once we do a simultaneous equation, once we solve the simultaneous equation, we'll be able to get the values of the two currents, I1 and I2, and that's how we can get a value of 4 amperes as the answer. Now, there is a faster way to solve this though, and I will also share with you this shortcut method. We know that current is inversely proportional to resistance, provided that the voltage across them is the same. So in this case, the two resistors have the same voltage across them because they are connected in parallel. And therefore the resistor with the higher resistance will receive less current out of the 6 amperes. The resistor with the lower resistance will receive higher current because they are inversely proportional. So we play with the ratio. We note that the ratio of the resistance top to bottom is 2 ohm to 4 ohm. So that's a ratio of 1:2. And therefore current being inversely proportional, we just swap the ratio around to become top path to bottom path 2:1. Alright, so this means that the total current of 6 amperes, they will be split in this ratio. 2 parts of it will go up to the top branch and 1 part of it will come down at the bottom branch. And if we do the ratio, this is how we can get 4 amperes flowing in the top branch through the lower resistance path, and then 2 amperes flowing at the bottom path along the higher resistance path, and that's how we can get the same answer, C.